All right, here we are with P4. Do a little bit of factoring. Another good prerequisite algebra skill that when you're working with expressions that are functions, you would potentially find yourself doing quite a bit. The first method of factoring will be common. It's where you look for expressions that just have, between the 2 or 3 terms to the polynomial, just have a factor in common. Like in the first one, 4 and 12, they both have 4. So I'd take the 4 out, and what would be left between the 2 terms would be x cubed plus 3. When you're taking out a common factor, sometimes it's a constant. Other times it can be a variable. So in this next one, I see 4 and 6. And I'm like, all right, I can take out a 2. But they also both have an x. So that would take my first term that I have here.
Good morning. If you haven't had your school picture taken, they are all set up for us and ready to go this morning. So head on down to the mezzanine if you haven't had your photo taken yet. Thanks. Have a great day.
I don't know if you heard that, but I've gotten my picture taken, so I'm good. If you couldn't hear that, then whatever. It was an announcement about getting your picture taken. Okay, back to business here. Okay, we take out a 2x, right? And then over here, where we took out 2x out of the last term, all we have left is a 2. Okay, again, the idea there that when you're taking out a common factor, you might take out a constant and a variable. Here we have it coming out of 3, and it looks like the only thing they have in common is 4, but I'm actually going to take out a -4, which would leave us with x squared minus 3x and then plus 4. Notice I take out the factor of 4 from those last 2 terms, but then the sign changes too. And over here, right, you've got these 2 terms, so I'm looking at this one and this one. Kind of a funky one, but the term they have in common is x minus 2. Once that's out, you have 2x plus 3 left. Okay, again, we'd call that common factoring. Let's get a couple rules. Difference of 2 squares. This one I think I actually showed you in P3. If you get into cubes, those rules get a little bit trickier. You'd still have the 2 parts classified as u and v, but you would have u plus v times u squared minus u times v plus v squared. And for the difference, you would have u minus v times u squared plus uv plus v squared. Okay? All right, let's put those to work down here at the bottom. So we'll completely factor these. So completely factor, if you get that instruction, that just means take it as far as you can, right, till you can't factor it anymore. For example, like right here, that's a difference of 2 squares. U is x, v is 9. And there you go. X plus 3, x minus 3. Here, on this next one, three 3m squared minus 48. Okay, first thing I see there is it's got a factor of 3. Let's take that out. Then I'd have m squared minus 16. But wait a minute, after we take out the 3, it turns into a difference of 2 squares. And I'll split that up into m plus 4, m minus 4. Here's our first look at the difference of 2 cubes, okay? So when I look at that, I'm like, all right, it's y to the third. 8 could be written as 2 to the third power. So now you see it really takes on that form where y is u and v is 2, okay? So then right off the bat, we'd have y minus 2. And then you'd have y squared plus 2y plus 4, okay? Now you've got a quadratic left on that second part after the y minus 2, but it can't be factored. So we'd say we've factored completely. All right, first thing first, right here, 3 comes out. 192 divided by 3 would be 64. Okay, so now it's looking like the sum, I'll get that rule back in the picture here, the sum of 2 cubes. So we still have this 3 out front. But now applying that rule, we'd have x plus 4. Right? As I'm applying this rule, remember, I'm thinking that x is u. Okay, and one other thing right here that maybe you couldn't quite see yet. To see the sum of 2 cubes, 64 is 4 to the third power. So for the value of v as I'm substituting, v is 4. That's where I'm getting that number. And then we'd have x squared minus 4x plus 16. And again, you've got a quadratic left, like right here. But you could try to factor that, which is a case like that is actually what we're going to look at on the next few problems, but it's not factorable, right? There's no, you have a coefficient of 1 right out here in front of the x squared. But you'd have to find 2 factors of 16 that add up to negative 4, and you're not going to find it, right? Nothing's going to add up to negative 4. All right, here's what we've got left. Okay. So a couple different cases to factor. When the leading coefficient is 1 and when it's not. You'll see in general, it's nice when it's 1, okay? So on this first one, I'm looking at, all right, factors of 12. It's pretty straightforward. I need 2 factors of 12 that add up to negative 7, which is going to be negative 3 and negative 4, which means this will factor to x minus 3 times x minus 4. Okay? I knew when I saw the 12 was positive, I needed 2 factors that were the same sign, either positive or negative, but because the middle term right here was negative, I didn't think about positive 3 and positive 4, because if I pick 2 positive factors of 12, they're going to add up to a positive number. So I had to have 2 that were negative. Just like over here, on this next one, if I'm looking at factors of 25, right, it's positive, but then I check right here, they need to add up to 10, so both numbers have to be positive, and that just reduces the number of factors that you would have to check. Looks like it'll be 5 and 5. And it'll look just like that. Okay. One more to go here. got to look at factors of -6. So the fact that that number is negative tells me I'm thinking through its factors, but I need one negative, one positive. Okay, and I immediately think of like these two scenarios. Those are the first sets that come to mind. This is the one that's going to add up to +1. So that would factor into x minus 2 and x plus 3. Okay? Pretty straightforward when you're talking about the leading coefficient being 1. Okay? Kind of a nice thing when that happens. The factoring tends to work out pretty nice. Well, what if it's not? What if it's not? What if it's not? Okay. It's a little bit trickier, but it's doable. There's a couple different methods you could use. I tend to use the trial and error method. Okay? Here's how it works. I look at the polynomial, and I see that, okay, I'm going to look at this first one. I can already tell right off the bat. This has got to be split 2x and x. I know that. And now I'm like, all right, I got to look at factors of -15, but it's not just as simple as, oh, which one adds up to +1, right? That only works if the number out front is 1. In this case, it's 2, okay? Now it's negative, so I start thinking of its factors, knowing that I need one positive, one negative. Okay, and what I do now, I'm pretty sure it's one of these two cases. So when you say trial and error, I just think of plugging them in and then FOIL it, and what's going to get you back to this, okay? You can do the foiling in your head, right? You don't have to, if it helps to write it out, that's fine. But I would see that if I put the -5 here, and I put the +3 there, okay? Now, when I think about the FOIL, I really don't have to do the first and the last. Those are going to work out. This is all about the middle term, okay? So when I do that, I'm like, okay, 2x times 3 is 6x, plus -5 times x is -5x. 6 minus 5 will get me to +1. Okay, basically, I might have to change the signs, I might have to change the numbers, but you're going to see in this trial and error method that within 2 or 3 cases, you'd have the numbers where you want them. Okay? Let's go to the next one. Now, I get that the first, right, those first 2 numbers, as I split up 3 and 2, they could be split up as 1 and 6, but I don't think they're going to be. Okay, I'm going to try this first, and then I'm going to go and look at 5. Okay, now this one gets really, really straightforward with the 5, because notice here, positive, positive. I only have one set of factors to check, 1 and 5. It's just a matter of where do they go. Is it going to be 3x plus 1 or 3x plus 5? Remember, I'm going for a middle term of 17, okay? So here, there's 15x plus 2x. That gets your 17. Again, if you flipped them, you would have seen 3x plus 10x, which would give you 13x. And that would tell you, hey, wait a minute, I don't want my middle term to be 13, I want it to be 17. I gotta try something else. If I had seen that both of those didn't work, then I would have gone to the 3x and 2x and maybe split it up as 1 and 6, but I was pretty sure I didn't need to do that. All right, here's the last one. With our trial and error method. I start right off the bat, and again, I'm pretty sure 15, yeah, like, okay, there's a possibility it could be split up 1x and 15x, but I don't think that's gonna happen. I'm gonna really look into this case where it's 3x and 5x, and now let's talk about factors of -15, okay? The one thing I know about them is both factors are going to have to be negative, right? That's a little clue as well. It's plus 15, but the middle term is negative. So here's what I got. Okay, that's a possibility. I don't think that's going to be it. My guess is that's the case to look into. Where would we put the -3? Where would we put the -5?
I had your picture taken yesterday. You can go down there right now. They're open and ready for you. Thank you.
Don't know if you heard that. Second call for pictures, but remember, I got my picture taken yesterday. And I totally nailed it, by the way. Did like the little, they like tilt your head to the side. Got it right on the first time. Perfect smile. It was a great picture, guys. You'll see it in the staff directory later this year and in the yearbook. Great picture. Okay. Where was I? Oh yeah, where's the -3 and the 5? A little bit of trial. And again, you really only have two possibilities. The -3 should go there. The 5 should go there. And again, I'll write this one out for you. On the whole FOIL thing, I'm just looking at this, the outside and the inside. But the way I set this up, the first is going to get me 15x squared. The last is going to get me 15. So I look at the outer, and I'm like, okay, that's minus 15x. Okay. Well, actually, you know what? That's not going to work. So, didn't plan on it this way, but this is actually really good because, okay, whatever. This works. It's called the trial and error method. When I wrote this out, I got my 3x and my 5x switched. I thought I was writing the 5x first. So, hold up here. Back it up. But what was catching me there is I'm doing the FOIL thing, and I'm noticing, like, hey, the way I set this up, that's not going to be -34, which means I put the -3 and the 5 in the wrong place. Okay, let's try it again. I should have put the 5x out front. That would go with the -3. The 3x minus 5. Okay, now I do the FOIL. This is what I was looking for. -25x minus 9x. There I get my -34. Okay. So that was good to see, right? Because when you're working on these problems, that's going to happen where like you actually put it in writing and then you kind of look at the FOIL thing and you're like, nope, that does not give me the middle term that I need, which, that doesn't give me the middle term I need, and that's okay, right? All that meant was where I had these two factors, they just had to get swapped. That's all there was to it. And again, if you kind of put together all the pieces with these, you find yourself that when you get to the trial stage of trial and error, I'm telling you, maybe 2 cases to look at, occasionally a third, but you're not going to wind up in a problem where it's like, oh, I've got like 17 different cases I have to check. Typically just 2 or 3.